Hello students, this is lesson 2 this week on Venn diagrams. So today we're looking at set notation and being able to identify regions in a Venn diagram. Okay, so let's get into it straight away. Apologies. The equipment you're going to need as usual is a pen or a pencil and a piece of paper to write on. You probably won't need a ruler today unless you want to be particularly neat with your drawing of the Venn diagrams, but it's there. Let's get into it. So starting with sets and set notation, it's not a massively drastically new thing. It's just a slightly different way of writing something which you're probably already used to writing. So a couple of new symbols are these curly brackets. So when I say that something's in the set A, then I might write an A with these curly brackets, and then I put all the numbers that are in that set inside it. So for example, A are odd numbers less than 10, so these are the numbers that are in that set, and you use curly brackets around the set. Okay, so 1, 3, 5, 7, 9, those are all the odd numbers less than 10, for example. Pretty straightforward. There are a couple of other symbols you may need to be familiar with. They're not hugely important, but it's just in case you see them in a question you don't recognize them. So this sort of curly E with a sort of tail, that describes your entire population. Okay, so they usually draw that at the top left corner on a Venn diagram. So that just sort of says everything is in the box somewhere. Okay, this will make more sense when I show you a Venn diagram. So we'll have a look at one of those now. So a Venn diagram is a way that you collect and sort data in sets. The reason that we use them is that it's a really nice visual way of showing those sets and showing where the data is, and also importantly the relationships between them. So basically it consists of a box with two circles inside it, and as I said earlier, this symbol here would represent the entire sample. So everything, the whole sample, will fit inside the box somewhere. You might have some numbers here outside the circles, you might have some numbers inside the circles, but everything is going to be inside the box. Normally you'll see the two circles like that, so you've got your entire sample inside this diagram. So for example, I might have I'm going to call this A, and that might be even numbers less than 10, and I'll call this B, and this would be odd numbers less than 10. So all the even numbers less than 10, you've got 2, 4, 6, 8, and that's it. All the odd numbers less than 10, you've got 1, 3, 5, 7, and 9. So those are even numbers, odd numbers less than 10. As you can see, there is nothing in the middle because there isn't a relationship between the even and the odd numbers, that can be shown in terms of nothing fits in set A and in set B. And there is nothing outside of the box because everything in my sample, the numbers 1 to 9, are in there. 1 is there, 2, 3, 4, 5, 6, 7, 8, and 9. All of the numbers are in there somewhere between 1 and 9. If, on the other hand, I'd have said to you, for example, that the sample is 1 to 10, well, now there's one number which isn't going to fall inside A or B. This is why. So I defined A, if you remember, as the even numbers less than 10, and I defined B as odd numbers less than 10. Well, the number 10 isn't in either of those circles because it has to be less than 10, all the numbers in A, and less than 10, all the numbers in B. So where does 10 go? 10 would sit outside the circles out here. Okay, so 10 would be a number that sits outside. It is an even number, so some of you might think, oh, it's supposed to go in A, but I did define A as even numbers less than 10. Okay, so 10, if my sample has to be between, everything between 1 and 10, then 10 sits out here, and now I've got everything in the sample is in the box. 1, 2, 3, 4, 5, 6, 7, 8, 9, and now 10 is also in the box. Let's take a look then at an example which has the set information given to us at the start. So set A contains the numbers 1, 3, 4, 5, 6 and 7. Set B contains the numbers 2, 4, 7, 8 and 9. Using set notation, that's what it looks like, and now we are going to complete this Venn diagram together. So straight away I can put in some of the numbers. So we'll start with A. I can put 1 in. 1 is sitting over here in the A circle. I can put 3 in there. 4 I'm going to leave for a minute because 4 you'll notice comes up here as well. 5 I can put that in. 6 I can put that in. And 7 again, I'm going to hold on to that one for a minute because that one actually comes in both sets. Now we'll look at B. So for B I've got 2, 4, 7, 8 and 9. So 2 can go straight in there. 4 I'm going to hold on to for a second. 8 and 9 go straight in. So I've covered most of the data so far. Most of the sample is in there. I'll just indicate what I mean by that. So 1 is in there, 3 is in there, 5 is in there, 6 is in there. And then from set B, 2's in there, 8's in there, 9's in there. The two numbers that I'm missing at the moment are 4 and 7. Now the reason I left those till last is because you'll notice they come up in both sets. Set A and set B both contain a 4 and a 7. Now that means that they need to go in this region here where the circles cross over. So that indicates where there are numbers in both sets. So I'll put 4 in there and I'll put 7 also in there. And now I can cross those off my lists. And I can say, well, I've got 4 and I've got 7, because if I just look at the A circle, A has got 4 and 7 inside that A circle there, and also I've got 4 and 7 inside the B circle. So if I sort of just focus on the B circle, 4 and 7 are in there. So that is now a completed Venn diagram. Now the intersection, this is another bit of terminology, a very important bit of terminology here, notation I should say. Intersection, that means that something is in both sets. Okay, so an intersection, that it refers to numbers that are in both of the sets, both of the circles. So for example, in this case 4 and 7 are my intersection. Okay, another way I can write this is like that, A and then that N looking symbol which represents the intersection, which I'd like you to have in your mind and perhaps write this down on the piece of paper you're working on. That symbol means and. So A and B, because that symbol represents something that is in this circle and in that circle. Okay. Union, on the other hand, this is a U symbol, represents anything that's in either of the sets. So the way that I'd like you to remember that, if again you're writing this on your piece of paper, is that means or. Okay, so you've got A or B, and that would be any of the numbers inside those circles. Okay, so if I list them, that would look like that. A or B is all of the numbers in those two circles. Now, in terms of the regions, you've kind of covered the first two already. A and B means the intersection, that blue shaded part. A or B means either of the two circles, so the whole thing is shaded. Now, the complement of A, don't worry too much about complement, but the apostrophe basically means things that are not in that circle. So, complement of A means everything that is not in A. So you'll notice I've shaded the whole diagram except for the A circle. Okay, so that means not A. So here's a question I'd like you to try. I'll just read the question out to you, then you can pause the video, have a go. So question reads, set A contains the numbers 1, 4, 6, 9 and 12. And then there's the set notation for that with the curly brackets. Set B contains the numbers 1, 2, 3, 5 and 12. Again, set notation. And then the questions. So number 1, complete the Venn diagram. Number 2, write down the members of the set A union B. Remember that union means A or B. And finally, question 3, write down the members of the set A with an apostrophe, which remember means not A, or complement of A, but not in A. Alright, pause the video, have a go at that question now, please. So the answer then to the question, firstly completing the diagram. I'll put the numbers in the middle. I can see 1 because it goes in both, 4 just in A, 6 just in A, 9 just in A, 12 is going to be in both, so that's going to go in the intersection. And then for B, well, I've already got 1, so I don't need to put 1 again. 2, 3, 5, and I've already got 12, so I don't need to put that again. So that is question 1 now done. Okay, now that's usually a 1 or a 2 mark question, very straightforward, just putting the numbers into the diagram. Part 2 requires you to actually remember and understand the notation. So A or B, that means anything in the circles. So that's the list of numbers that are in the circles. 1, 2, 3, 4, 5, 6, 9, 12. That's all of those numbers. And finally, write down the members of the set A with an apostrophe. That means not in A. And, well, that will include anything not in this circle here. So if I just show you what I mean by that. Anything not in that red circle just there. So that will be the 2, the 3, and the 5. Okay? Okay then, so this is the main task for today. What I'd like you to do is to click on the link. This link is on your class charts homework that was set. Alternatively, if you haven't got access to that for whatever reason, you can type the link in, this link over here, and complete that matching up activity. It's about regions and the notation, so you have to match up the diagram with the correct the correct set notation. Okay, just remember your and your or, the intersection and the union, and you should be fine. Please take a picture of your completed your score at the end of completing that game and upload this to class charts as normal. Thank you very much, and good luck with that.